This is the Big Idea screencast. My name is Clifton Craig. I'm an iOS developer with a passion for Java and Android. In this demo, I'll create an example Android chat application using IntelliJ Idea. The name of our chat client is Scribe with an R. I prepared an example of this chat client to give you an example of our end goal. Here I'll open our project. Using IntelliJ, then we'll click the Run button. It's compiling in the background. We'll bring up our emulator, go back to IntelliJ, and choose a running device. We'll go over to our emulator to wake it up. Click OK to push our APK to the emulator. Watch it upload. The application will launch. We have a logo. I've defaulted the user ID and password to Cliff and Craig respectively. We can click Login, and we're connected to the chat. You can type chat messages in, and artificial intelligence from the Jabberwocky backend server will respond. You type a chat message, you get a witty response. Chat messages are sent over the network, and the artificial intelligence responds accordingly. As you can see, I have some pretty big ideas that I'm willing to share. I've created a stub of this project in Eclipse and checked it out to my hard drive. Here we import our Eclipse project into IntelliJ. We'll navigate to the Scribe folder underneath the Big Idea Live subdirectory and open the folder Scribe. Inside this folder we have a .class path and a .project Eclipse project settings. IntelliJ is noticing that this project can be opened directly, so it decorates the folder with an IntelliJ icon. IntelliJ can also handle other project types from Eclipse to Maven to Flash Builder and Gradle. We click OK. And we walk through our import dialog. We select Eclipse. We go Next. We use the defaults here. You can use this screen to modify how IntelliJ keeps in sync with Eclipse if you have other team members working on the Eclipse project and making further customizations. It's best to keep the defaults unless you truly know what you're doing. We'll click Next. Here it detects the Scribe Eclipse project. We click Next. Here we arrive at our Sdk Selection screen. We can see the plus and minus buttons for configuring additional or removing SDKs. Java 1.6 is the default. We have SDKs for all the various versions of Android. We have a couple of Ruby SDKs, Lua and Kahlua. IDEA supports various programming languages. In our example, we're going to take the 4.1.2 Android SDK. We click Next, and we click Finish. As the project opens, you are prompted to configure your Android settings. Let's take care of that now. In our settings configuration screen, we click the plus button to add an Android framework to our module. You can see the red squiggly line, and hovering over it indicates there's a couple of errors in the dependency list. We can either go to the Dependencies tab directly, or we can go down and click the Two Errors Found hyperlink button. Clicking this reveals the dependency issues. What it's revealing is the Eclipse Android libraries and the Eclipse ADT framework in our dependency list. To remedy that, we can click the Navigate to Error button, which brings us to our dependency list. We can highlight these two dependencies and remove them. Navigating back to our project, you see you have the typical gen and source folders. We have our launch activity open in the default editor. Keep an eye on the lower left hand corner of the screen, as KeyCaster will be highlighting my hot keystrokes. Taking a Command B will navigate to the definition of the layout main symbol. That brings us to the IntelliJ Visual Designer. The IntelliJ Visual Designer allows you to edit your Android layout files in either visual or text layout modes. What you'll notice is a graphic representation or approximation of what your screen will look like when it is rendered on an Android device. On the right is a palette of widgets which you can drag and drop into the design view. On the left is a design view tree hierarchy. Here we create a run configuration for our activity. We click Edit Configurations, and that brings us to a list of all the different configurations you can create for running activities, applications, and so forth. These are all default configurations. We can click on any one and edit the way that IDEA creates further application or run configurations in the future. In our case, we want to take the plus button in the upper left hand corner and click Add New Application. We'll give our run configuration a name, Scribe. We'll select a module. Here, you can customize your run configuration. We'll select the Show Chooser dialog to control which device we want to push to, a physical device or an emulator. We click Apply, then OK. And now we can run our application. As it's compiling, we can watch the progress in the status bar. As it finishes compilation, our Choose Device dialog pops up. We select our emulator and we click OK. Open up our emulator screen, and eventually the compilation progress will push the device or push the APK to the device. Our app launches, and this is exactly what we saw in our UI design view. And now we get into the Visual Designer mode of IntelliJ Idea. We'll take a Command B to walk to the definition of the layout file. This is an approximation of what we saw on the device when we ran it. We can click our left hand pane to expose the component hierarchy. We'll start from scratch. We can drag a frame layout to the component hierarchy, or we can delete that and drag the frame layout directly onto the screen representation. We'll nest a grid layout in the middle. And now we'll start dragging and dropping some widgets. We'll start with a text view, which will be our username prompt. We'll use an edit text to collect the username information. Another text view for our password. And another text view to collect the password information. Let's drag our checkbox out. Position that directly underneath of our password. Double click and enter the Remember Me text, making sure that it's checked by default. Drag a login button, double click it and change its text. And now we can click the individual items and edit their properties in the Properties view. We want our layout to wrap content here for height and width. That puts it neatly in the center. Let's make our login button gravitate toward the right. We'll take an image view for our logo. We need to find the source property. Click the ellipsis and select our logo from the resources folder. That's way too big. We'll change the sizing a little bit to make it fit neatly at the top of the screen. As you can see, as I enter the properties of layout, width and height, the properties change and the visual representation changes real time. We drag a motivational text view for the bottom because we always want to expect more from our tools. And let's put some padding all around, about 5 dp. At this point, we can double click or click and highlight both of these text fields and change their attributes together. We want the width of these to be a little bit bigger. Let's see, 150. I'll try 200. Is that right? It looks a little wide. We'll go back to 150. As you can see, we can highlight these two text fields, text labels, and change their padding. Add a few pixels to the right of those. Now I want to talk about some of the more powerful refactoring and hotkey combinations available in IntelliJ Idea. You'll note the little light bulb icon warning us of potential problems. It says we have a hard-coded username string. You don't want to do this in Android development. We hit Alt-Enter to reactivate the same warning prompt. We hit Enter to select the warning, which will take us to a dialog which will allow us to extract the hard-coded reference into our string's XML file. You enter the resource name. You'll note that the file name is defaulted to strings.xml, and it's going to fall into the values folder under our resource directory. Rather than fix that immediately, let's back up a minute and talk about the design view versus text view. We're in design view. We can activate the text view tab here to look at the text representation of our Android layout file. In here you'll see the XML and the username hard-coded string. You also have definitions for all the other widgets on the screen. Taking note that our username is hard-coded, we'll go back to our design view. We'll hit Alt-Enter and repeat the steps to fix our username, coding it as a username.prompt resource name. We briefly verify the extract string using the text mode. We note the username prompt reference and hit Command-Alt-V to jump to the definition of this reference. Once inside the strings XML file, we can verify the file's location within the project using the Alt F1 quick lookup feature. We select the project location to open our project view and verify the location of the strings file. We navigate back to our layout, and then we begin extracting the rest of our strings, letting IDEA do all of the heavy lifting for us. Password prompt. Remember me checkbox. Login button. Next, we fix the contents of our edit field for the username prompt. Then we activate the intention, which tells us to supply an input type hint. We want to add a text password hint. We want to remove the contents of this field. However, let's observe how entering a value into this field echoes the little dot characters rather than text. Now let's run our application. We choose a device, wake up the emulator, watch it deploy, and that's our login screen. The very next thing we'll do is open our design view, find our login button, and add an on-click action. We'll assign an onLogin method to respond to this click event. Note the little M decoration that indicates a method call. We go into our launch activity, Command-Shift F12 to focus exclusively on the editor. We add our onLogin definition here. Here you'll see IDEA's strength as a Java editor. As you type, it will suggest sensible completions and sensible variable names. For example, the view with a lowercase v. We note the import prompt of the parameter type. Hitting Alt-Enter will allow us to import its suggested type. Let's look at our imports. They are initially folded away. However, you can expand them hitting the plus button, or you can hover over them to peek at them. Coming back to our onLogin method, let's pretend we had a chat activity. We want to start this activity here. The name is flagged as an error since it isn't defined. However, IDEA allows you to continue to write code against undefined references and come back later to have it stub out the definition. Alt-Enter will define a stub of our chat activity. Dropping into the chat activity, we see a prompt to add our new file to Subversion. Never touching the mouse, we hit Enter to accept the default answer of yes. We see the name text change from brown to green. A green file indicates a new file added to version control, where brown indicates a file that has not been yet tracked by version control. We'll make our chat activity extend the list activity. We hit Alt-Enter to add our import. We want to hit Command-O because we want to override the onCreate method. Here we call setContentView. Again, we refer to something that does not exist. This will trigger an error. Here we use Shift F2 to walk backward to our error. But if our cursor were higher up in the editor, we would hit F2 to walk down to the error. We hit Alt-Enter to get our suggestion to create the resource file, chat.xml. Accepting the suggestion, we get a new resource file dialog. Here we define our root element. This dialog supports code completion. A few keystrokes and a couple of taps generates a basic layout, adds it to Subversion, and finally we can fill out the new layout file. Let's speed through our layout definition. Now we have a workable chat activity. We can go to our chat activity Java source and walk back and forth between it and our layout file using IDEA hotkeys. Next, I want to define an onSend method. I'm thinking I will link this to the send button to send our chat messages to our buddy. We can do this the old-fashioned way, typing out our method definition. We can struggle with method keywords, defining arguments, and eventually adding imports. Or, let's cut this code out and try something different. We open our IDE settings using Command Comma. I'm looking for file templates here. There are lots of options here, so I'll use an incremental search. Typing in templates, looking at file templates. Actually, I believe I want live templates. File templates are used from the new file dialog for defining entire file snippets. Live templates can be embedded within a file. We click the plus sign to add a new template. Our template is for a new method stub. However, we want to create an abbreviation for autocomplete. We'll set a description. We paste the text we cut from the editor. We specify $delimited variables for our template. These variables become placeholders that you can tab through during autocomplete. You can click the Edit Variables button to further define them. Let's add some default values. We want a default for our name. Default type would be object. And let's say arg would be the default argument. We now need to set a context for our template. Templates can be associated with various programming languages and contexts within a language. I'll expand the Java context. If I wanted my template to expand in the middle of a statement, I would select Statement. In our example, we only wish our method to expand as a declaration. We will also add it to a list of smart type completions. We note that the tab key will be the default for expanding our template. Going back to the editor, let's use our new template. Type the abbreviation and hit tab. We can name our method stub. And we can tab through the variables we created in our template. Now let's fix our formatting, which I intentionally left awry. We highlight the block and hit Command-Alt-L and Enter to take the default. Let's navigate back to our design view. I click the Send button, Then I search the properties for the onClick property. I use only my keyboard to navigate down a list of defined methods and select the method that I just defined. Now we need to add an ID to our message edit text control. This will let us locate it in code. Back in our chat activity, we've added a toast pop-up that wants to show the text from our message control, so we need to define a local field to refer to this control. Using autocomplete and a couple other hotkeys that we've learned, we can easily add the field. Now to make use of our field in our pop-up, we use autocomplete to refer to the field and call its getText method. Autocomplete tells us that our message text does not have the method we need, a sure sign of problems. We need to change the message text type from the more generic view to a more specific edit text type. We use F2 and Alt-Enter to fix our problems. Now we want to use encapsulation for the message text rather than direct reference. We select the field and use Command-Shift-A to look up the encapsulation refactor action. You can use this shortcut to find every other shortcut in IDEA. We type encapsulate to search our action list, taking the encapsulate fields action. In the dialog, we select our message text edit text. This will generate getters and setters and add the public accessor. Now we'll go back to our manifest and add our new activity. In a manifest, we use autocomplete to enter Android-specific attributes and also to look up the Java class names for the activity. We add a description, or rather a label, and we will run our activity. We click our login button, enter a message, and look for our toast. Doesn't seem that our toast message is coming up. We need to debug. While the emulator is running, I can click the Attach to Process button in IDEA to show a list of running processes on my device. Selecting the process, we go back to our editor to add a breakpoint on the onSend method. Right-clicking brings up a list of options that allow you to edit the breakpoint. The Suspend checkbox controls whether we want to suspend the program while a breakpoint is reached. We'll deselect that. There's also a condition control that will cause the breakpoint to be hit under specific conditions. We'll just select the log message to console option so we can verify we're invoking the method without interrupting the flow. We refer to the console to find the debug log output while the program runs. Going back to the emulator and hitting the send button, we're seeing that we are reaching the breakpoint in our onSend method, but we're still not seeing our toast. We double check our logic and we see, oh, we've forgotten to call show on our toast. We remove the breakpoint and relaunch our app. We log in again, type our chat message, and we have our toast. Now that we have the majority of our project fleshed out, I want to add the remaining business logic. But first, before we do that, let me introduce IDEA VCS support. I've opened the Changes view at the bottom where we see a list of all changes that are being tracked by subversion. You can see both new and modified files here. Changed files are marked blue, new files are marked green. Command D gives a side-by-side diff. We'll Command D on our launch activity. In our side-by-side diff editor, we can use hotkeys like Alt-Enter to do quick fixes while we compare and merge. We can omit changes individually, or we can use Command Z to undo those omissions. We can click on icons in the gutter like this one to navigate to overridden definitions. This is not the best example as it took me to the Android compiled definition. I'm going to commit all of our work so far. Now, after making a commit, you would normally start work on another set of changes. These changes would usually be associated with a future task from your sprint backlog. Change lists allow you to work on multiple features at once while isolating the impact of files associated with one feature from another. We can create a change list in IDEA to represent the feature or task we're working on. Here we'll create a new change list for our chat screen work. Our new change list is now the active change list. Let's make a change to this file. Say we want to capture a particular variable as a field in our activity. These changes are immediately reflected in the change list as it updates to include one file. Now we want to bring in a third-party API. We'll go out to Finder, where I locate the Chatterbot API, which provides the artificial intelligence for our app. We'll drag and drop that into IDEA. The drag and drop triggers a move file action in IDEA, and the file is moved into the lib folder. We accept the prompt to add to Subversion. Now we can see both files in our change list. Let's move our API jar to a new change list devoted to third-party integration work. The new change list becomes active and our chat activity is still in the other change list. Now, with our third-party integration change list, we want to use the API by calling into it from our chat activity. I'll find and paste code from the already finished product here. We see IDEA notifies us that a file from our non-active change list has been modified. This would be a common problem in development, as partial changes for unfinished work often get committed. Here we have the option of moving our changes, switching change lists in case we actually wanted to work on the other feature, or ignoring the warning altogether. In our example, we want to move our changes to the other change list, since we're doing third-party integration work. After moving our work, we no longer need the other change list, so it's safe to delete it. I'll grab the chat adapter from our finished product to handle the chat list. Holding the Option key while dragging and dropping from Finder into IntelliJ triggers a copy rather than a move action. We'll go back to our chat activity and fix the remaining errors using IDEA hotkeys. While integrating our API, we've been asked to supply a default username and password on our login screen. When our third-party change is in flight, we make use of a get stash-like feature that lets us put our changes on the shelf. Shelving changes allows you to work on another feature without accidentally committing incomplete work. With this action, our work is reverted. After moving our changes to the shelf, we can reactivate the default change list and get rid of our old change list. We open our login layout and continue with the new changes. I'll launch the activity to verify the default name and password. Now I'm ready to commit my changes for user defaults. My change list only has the one main XML file with my defaults. We supply a commit message, and commit. I can now revisit my shelf and restore my earlier changes. I can put them into an existing change list or a new change list using the original name. Here we're prompted to add the new files to Subversion. We're ready to run our last round of changes. We'll push to our emulator. The app launches. We can log in, and our work here is done. Thank you for watching. This concludes the Big Idea screencast. Look for future screencasts on topics such as test-driven design and Maven.